So, not what we just did with radicals and complex numbers, but before that we were factoring, correct? When we were factoring, what was the point of it? What was the point of us factoring? We had to find the GCF, we had to use the super X, but what was the point of factoring? You don't remember what it's called. So to get to... So when there's an equal sign, what does that tell you have to do? Solve. Right? So we factored, and then we factored and solved. Yes? No equal sign means you just factor and you write your terms. The equal sign tells you you're going to get a value for the variable. Okay? What are some words we use for that value of the variable? There are 4. Solution. Zeros. What did you say? Oh. 2 more. Solutions. Zeros. Not y-intercept. X-intercept. I think I heard it. Roots. Solutions. X-intercepts. Roots, zeros. And what does that actually mean when I solve and I find that? Where it's going to be where on the graph? Where it's going to cross the x-axis. Okay, so factoring is one way we can solve for that answer. Square roots is another way. So at the end of this, you're going to have 4 different ways you can solve. Some are easier than others. Some are quicker than others. One way will always work no matter what. So eventually, I'm going to give you all the tools, and then you decide how you're going to solve. So factoring was our first tool. Okay? Square roots is now going to be our second. Now, before we solve for square roots, because we should be really good at simplifying square roots by now, right? So if I gave you... actually, before that, what's standard form for a quadratic equation? Standard form for a quadratic equation. Who remembers standard form for a quadratic equation? No. That's the Pythagorean theorem. Quadratic equation, what's standard form? A plus BI is for complex numbers. Standard form for a quadratic equation. I know the answer. I want to know that you know the answer. And most of you got a perfect score in your notebook, so you can find it. Anyone? You should look. I'm not going to tell you. You tell me. Standard form for a quadratic equation. Someone found it for you, and he's going to say it a whole lot louder. Here we go.
ax squared plus bx plus c.
Ax squared plus bx plus c. Was that not the form that all of our equations were in before we started factoring? The answer to that would be yes, right? Do you remember that assignment where you had a problem that looked something like this, and you're like, I don't know how to factor that? What did we do? What did we have to do? Can I factor this just like that? No. When am I allowed to factor and solve? What has to be here? A 0, right? It has to be set equal to 0 in order to factor and solve. So how do I set this side equal to 0? Add 5 to both sides. So you'd get 3x squared plus 7x plus 5 equals 0. This allows you to factor and solve. Okay, standard form. Gonna be important. Maybe you should like box or highlight or something, because I'm gonna ask you that question a lot in the next month. Okay. Now we should be really good at simplifying a radical. So I'm gonna give you a couple that I would like you to simplify. So take a second and simplify those 3 radicals. All right, give me 2 numbers that multiply to 72.
12 and 6.
Okay, 12 and 6. And then 12 breaks down to 2 and 6, right? Or 4 and 3, however you want to do it. But I see a pair of 6s, so I'm going to stop there. And I have a leftover 2. Right? Your final answer should have been 6 square root of 2. Did you get that? Good. Number 2. I'm going to break down 150. Give me 2 numbers that multiply to 150. 15 and 10. And then 15 breaks down to 3 and 5, and 10 breaks down to 5 and 2. So I have a pair of 5s, a leftover 3, and a leftover 2. That 5 is going to come outside what's already there, though. -4. So -4 times 5 is -20. And then I have a leftover 3 and a leftover 2. 3 times 2 is 6. Okay. And then number 3, if I break down 30, I get 6 and 5, and 6 breaks down to 2 and 3. Do I have any pairs? No, so all of this is going back inside. Is there anything else you noticed? You have a negative under the radical, which tells you what? It comes out and becomes an I. So I have a 5 there. That I comes out. 2 times 3 times 5 is still 30. How'd you do on those? Okay, easy. Other than the fact that I said simplify the radicals, what would indicate simplifying versus solving? An equal sign, right? So if I don't have an equal sign, I'm going to simplify. So we just spent the last week on simplifying radicals, simplifying complex numbers. Yes? Whether you liked it or remembered it, we did it. Okay. So what if I give you a problem that looks like this? So without any directions, right, I'm just giving you x squared equals 9. What do you think your ultimate goal is? To what, I'm sorry? To solve for x. Everyone agree that because there's an equal sign, I have to solve for x. Okay, so let's think back to IM1. To solve for x, the whole point is to get x by itself, right? Right now I have x squared. How do I get rid of an x squared? Square root. Whatever you do to one side, you have to do to the other side. So the square root of x squared, we've talked about that, is what? X. And the square root of 9 is 3. Now I want to think about this for a second. So this could be a quadratic if I rewrote it, right? Like it could be in standard form. If I were to set it equal to 0, what would I have to do? So I have x squared equals 9. If I wanted to set it equal to 0, what would I have to do? Subtract 9. So I would get x squared minus 9 equals 0. Does that look familiar to you? To two people? Yeah, so someone other than this front group right here. What does that look like to you? Anyone? Okay, talk to your group for 15 seconds. What does this look like? This right here. What does this look like to you? Have you seen this before?
Yes.
Yes. I mean, I agree that you have, because I'm pretty sure I taught it. Mr. Garza has seen it before, because he was here when I taught it. What is that? What do you notice about it? Nothing. Great. Someone tell me, what do you notice? There's nothing that you notice about this problem? Oh, Lord have mercy.
Not when I'm the quiz yesterday.
You really notice nothing about this problem? Not one person in this classroom.
What?
Yes.
What?
You have to solve. Darian, will you say that louder?
Say it again.
Difference of squares.
Difference of squares. It's special. This equation is special. What would I normally do with that equation? Over the last 3 weeks, what would I have done with this equation? It's already set equal to 0. What would I have done now? How would I have solved it? Y'all, okay, hold on. Hold on. We literally talked about this 2 seconds ago. When you are solving and it's set equal to 0, what do I have to do to solve? I think I heard it. Starts with an F. Factor. Oh my goodness. You would factor. How do I factor? What are my options? What's the first thing I start with? Greatest common factor. Is there a GCF? No. Okay, so what's my next option? Super X. But I just told you it was special. Do you remember what to do with this special one? Obviously, I'm going to go with obviously not. So let's Super X it. Okay, we're going back to factoring for a second. It's not going away, guys. The whole first month of IM3 is factoring. You have to know how to factor. What is A? 1. What is B? Oh my gosh. This is super painful. What's B? 0. What's C? -9. You literally just wrote down standard form of an equation. A is in front of x squared. B is in front of your x. C is your constant. Okay. What goes on top? A times C, so -9. What goes on bottom? 0. What goes here? 1x and 1x. You are now looking for two numbers that multiply to -9 and add to 0. What multiplies to -9 and adds to 0? 3 and -3. 3 times -3 is -9. 3 minus 3 is 0. You should be writing this all down. From here, I am writing it as factors. X plus 3, x minus 3 equals 0. How do I find those solutions? How do I actually solve? Okay, set each factor equal to 0. So x plus 3 equals 0, x minus 3 equals 0. Which means x equals negative 3 and x equals positive 3. Do you agree with that? Okay. Now we need to look at our answers for when we factored versus when we took a square root. Why is it that I have the exact same problem? I just rewrote it, but it's the exact same problem. Why is it that I have 2 answers here, but only 1 answer here? Because it what? No. But I'm thankful for your answer. Why is it that I have 2 answers here and 1 answer here? Okay, so here's my next question to you. Do you agree that 3 squared is 9? Is there anything else that I could square to get 9? Negative 3. What's negative 3 squared? 9. Okay. So here is something that you have to be very careful of, which most people will miss for a bit. When you are solving, so when you actually solve, not simplify, when you solve by taking square roots, you always have 2 answers, a positive and a negative answer.
Do I want to highlight that?
We're going to write it down.
The star next to it.
When solving by taking square roots, and again, solving means there's an equal sign. When solving by taking square roots, you always have 2 answers, a positive and a negative. When solving by taking square roots, you always have 2 answers, a positive and a negative. Now, the basics of taking square roots is probably easier and quicker than factoring, which is why I'm giving you multiple methods on how to solve. But you can't forget one of them. What do you notice about taking square roots? What term do I not have? A b term, right? If I have a bx, I can't solve by taking square roots. That other variable kind of eliminates that for me. So then I'd have to factor until you learn something else. I'm hoping our brains will wake up a little bit. All right, let's look at another one. So I'm going to give you the square root of 169. Now it's equal, so I'm solving. Has an equal sign, so we solve. And how do we get rid of an x squared? Square root, whatever you do to one side, you have to do to the other side. What's the square root of x squared? X. Careful with this next question. I'm solving. What's the square root of 169?
13.
I'm solving. Plus or minus 13. You are solving. Anytime you solve by taking square roots, you have a plus and a minus of that answer. Okay, try this one. we're going to take a square root of both sides. We're solving. The square root of x squared is x. The square root of 100, because we are solving, is plus or minus 10. Okay? Let's look at x squared equals, we're going to do this one together. X squared equals 84. We're solving it the same way. So to get rid of the squared, I take a square root. Square root of x squared? X. Is the square root of 84 a perfect square? No. What do you know about radicals? You can simplify them. So give me two numbers that multiply to 84. 6 and 14? Okay. 6 breaks down to 2 and 3. 14 breaks down to 2 and 7. I have a pair of 2s. I have a leftover 3 and a leftover 7. So what comes out? The 2. I'm going to actually write this down. The 2 comes out. And inside is 3 times 7, which is 21. Is that my final answer? How many answers am I supposed to have? 2. 1 plus, 1 minus. If I were to write these as 2 separate answers, because we're going to eventually have to do this, but if you were to write these as 2 separate answers, it would literally be 2 square root of 21. That's the positive answer. And then negative 2 square root of 21. So if you were to break them apart and write them separately, that's how you're going to write it. Same thing here. I would write positive 13, and I would write a negative 13. Okay. Try this one. Oops. Ignore that. Hold on. X squared equals 63. Someone walk me through it. Who wants to? Annie wants to help me?
Not yet. She's
Not
been
yet.
in her season.
Who can help me? What do I do? A lot of you had right answers.
Yeah, they did. You guys are doing it right.
Square root both sides. Square root of x squared is x. 63 is not a perfect square, so I'm going to simplify it. Give me 2 numbers that multiply to 63.
7 and 9.
Okay, 7 and 9, and 9 breaks down to 3 and 3. So I have a pair of 3s and a leftover 7. X equals plus or minus 3 square root of 7. Okay? Are we okay with that? Okay. I'd like you to try this one. If I am simplifying, I'm going to take the square root of both sides. Not the issue. You broke down 32 and said probably 8 and 4, and then 4 and 2. You stopped because you had a pair of 4s and you had a leftover 2. You also notice, most of you, that there was a negative underneath the radical. So the 4 comes out, the I comes out, the 2 stays inside. This was the answer that I initially checked from 80% of the class. We are solving by taking square roots. What am I missing? My plus and my minus. Anytime you are solving by taking square roots, you're going to have 2 answers, a plus and a minus. So you remembered the I, you forgot the plus minus. I want you to be very cautious as you go through problems. Some of them aren't going to have an I, some of them will have an I. Okay?
Have you showed them the picture of why that's a plus and a minus too? I thought you showed
Yeah, I mean, but it's showing them here too. So yes, when we're graphing, you'll have the 2 answers. On a scale of 1 to 5, 1 being I have no idea what we're doing, 5 being I got this even if I forget to do the plus or minus. Where are you at?
1.
Okay, 4s and 5s. Hey, we said that last time and then we didn't do so well in our quiz.
By we